Spring balance. Objective: to understand the principle and working of a spring balance. A spring balance is used for measuring the weight of an object. It works on the principle of Hooke's law, which says that the elongation of a spring is directly proportional to the load supported by the spring. Hooke's law can be stated as F is equal to minus K multiplied by X, where F is the load attached, K is the spring constant, and X is the elongation of the spring. The deformation of the spring and load attached are related linearly, meaning the elongation or stretching of the spring will double with a doubling of any weight hung from it. The spring balance consists of a steel spring. Its upper end is attached to a support, while the lower end has a hook attached so that objects can be suspended from it. The spring itself is typically enclosed inside a metal casing, and there will be some form of a pointer that can slide across a scale of measured increments indicating weight. The initial reading on the spring balance will be calibrated to 0 on the scale. When a load is attached to the hook, gravitational forces will pull the spring in a downwards direction. Conversely, the force of the spring will pull the load in the opposite direction. Once these two opposing forces, the forces of gravity and the spring, are balanced, the load will become stationary. The pointer will move along the scale, stopping at a reading which will give the weight of the load. The scale is usually marked in newtons and grams. Summary: the spring balance works on the principle of Hooke's law. The spring balance is used to measure the weight of a body that is attached to the hook of the spring.